So today we are going to be discussing the percentage abundance concept. Okay, previously this question of percentage abundance wasn't used to be that tricky, but recently the examiner has increased the difficulty level of the percentage abundance concept, and examples are these questions from October-November 2024. This question, it was found extremely challenging, and this question as well, it was about percentage abundance and was found extremely challenging because examiners basically changed the style of the questions. Previously you just had to use this formula of mass into abundance plus mass into abundance over sum of abundance, and this formula was quite easy. You just had these mass numbers, you had these abundances, and you would apply the formula and you're going to get the values. But now the style of the questions have changed, and these questions, they require the concept of percentage abundance to be instilled, and many of you were finding it difficult. I hope inshallah after this video you're not going to find it difficult. Just watch it till the end. So let's get started. I'm going to give you the concept, and I am sure that concept is going to be what's going to be applied. The formula alone won't help you if you don't have the concept, and trust me on this when I'm saying this. Okay, percentage and abundance concept. Basically, first step number one is that you're going to have the mass number, you're going to have two mass numbers. Okay, you're going to have two isotopes and you're going to have the mass number of those isotopes. Okay, you have chlorine 35 and you have chlorine 37. Okay, you know what is the mass number? I hope you guys know. It is the number of protons and neutrons inside the nucleus of an atom. So chlorine 35 basically has 35 nucleons, which means 35 particles inside the nucleus, and 37 has 37 nucleons, and this is the percentage abundance. Okay, now what's abundance? Abundance basically just simply means the availability of that thing in the environment. Okay, if I say that I have 5 black shirts and I have 2 white shirts, so the abundance of 5 black shirts is more because I have more in quantity, and the abundance of white shirts is less because I have less in quantity. So that's simply the availability of a substance, how much of that thing you have. So that's your percentage abundance, and this abundance plays a great role in your AR, or finding the relative atomic mass, which is the AR. How does this play a great role? Let's see. Okay, now step number one is very easy. You just have to create your boundaries. Okay, now you have been given with the mass number, you've been given with the percentage abundances. So two things that you should know is that your lowest possible mass can be 35 and the highest possible mass can be 37. So you know that your AR, what you're trying to find, is going to lie between 35 and 37. That's what you should know, that it's going to be in between these two. So you just write 35 over here, you write 37, and you know in your mind that it's going to be something in between. Okay, so AR is in between and these are the abundances, and what you are finding is in between these two. Okay, now your step number two is a bit kind of understanding that mass or AR will be towards the mass that has more abundance. Okay, so if I talk about this case, okay, I know the middle of these two. Okay, what's the center number is going to be 36. I know between 35 and 37 I have 36, so 36 is the exact center of these two. Now I have 25% abundance of 35 and I have 75% abundance of this thing. Okay, so I know that this thing is more in abundance, this 37 is more in quantity, so my AR is going to lie towards this side. Okay, it's going to be more than 36. Okay, it's going to be in towards 37 because this is more in quantity. So that's the concept, that the thing that is more in quantity has more abundance, the AR is going to be towards that side. So it might be 36 point, it can be 36.7 or 36.8 or above 36. Why? Because 36 is the center and abundance of this is more, so it has to be more than the center. Okay, now one other concept over here is that if you have both in 50% abundance, that means that both are equal in amount, so the AR is going to be exactly in the center, it's going to be 36. Okay, if you have 50% abundance of this, 50% of abundance of this, it's going to be in the midway between 35 and 37. So it's about just thinking that the thing that's more in abundance, the AR is going to be towards that side. So if both abundances are equal, then the mass is exactly in the midway. So the more you have something, the more the mass or AR is going to be towards that thing, and if both are equal in amount, then it's going to be exactly in the midway. I hope this concept is clear. Okay, now you have to think about this thing similarly, that since 75% is more than 25%, okay, so this thing is more than this thing. Okay, 37 has a greater abundance. So our mass should be towards 37. So we know that between this is the boundary, and the boundary is 36. Okay, this is the boundary, the center boundary, and if both were 50-50%, it had to be 36, like this. But now this is more, this 37 is more, so our AR is going to be towards 37, so it has to be above 36. Okay, it has to be above 36, and it's anywhere between 36 and 37. Okay, I hope you get it. Since it cannot be in the midway, it has to be above 36. So that's a general concept that's going to help you solve the questions. Okay, so I hope this all was clear. Now let's try to solve the questions with the concepts we have. And this formula is, I hope this is a simple formula that all of you know, and this needs no explanation. You just have to put the mass, which is 35 for instance. The abundance for 35 is 25%. You have to write it. Plus you have to write the mass of other thing, which I guess was 37, and you have to write its abundance, which is 75, upon sum of abundance. Now why I've written sum of abundance? Sum of abundance means this was your abundance number 1, this was your abundance number 2, and this was a percentage. And you know that the sum of 75 and 25, I guess that's pretty obvious, it's going to be 100. So the sum of abundance is going to be 100. I want you guys to work with sum of abundance, because that's going to help you. Don't always just write 100 in the denominator. If it's a percentage, then you can write 100, but otherwise the the real formula is sum of abundance, and you're going to see it later on when we solve the MCQs, that why it's sum of abundance. Okay, now formula only works when you have numerical values, but in MCQs sometimes examiner tests concept without numerical values, and that's very common in recent past papers. So we're going to practice this sum and understand all that I just told you guys. Okay, now an element has two isotopes, okay, of relative isotopic masses of x and x plus 2. Okay, so that's the sample we have. We have this mass and this mass. So this x and this x plus 2 is basically, what is this? This is not some random numbers. This is the mass, okay, the mass. And now the diagram shows the composition of atoms in the sample of the element. Now this is the sample we have. Now some of you might think that, oh, we have the mass and we have a sample, and they're asking about the relative atomic mass of the sample. How can we figure out? We have given with no abundance, there's nothing, and we have this formula, how to apply this formula and how to do things. Okay, don't get confused. Simple thing is that consider this to be your sample. Okay, this is your sample, and now you can simply calculate the abundance from this sample. How to calculate the abundance of this sample? Simply count. What is the total? The sum of abundance. Okay, you need to apply the formula. It's good. What is the sum of abundance? First find the sum of abundance. Sum of abundance is going to be all these together. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the sum of abundance is 12. So total sum is equal to 12. Okay, now the second thing, how much abundance is of x? Only x we are finding the abundance of. So x is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 upon 12. Okay, 12 is the, you should know how to write percentages. 9 is of x and 12 is the total. So 9 upon 12 of my mass equal to my the mass of x. Okay, and now I have to find the second, the abundance of second mass, which is x plus 2. X plus 2. And let's find it. It's 1, 2, and 3. And 3 upon 12 is going to be my, abundance of my second mass. Okay, now one thing I told you guys. Okay, you have two masses, x and x plus 2. And if you try to now visualize this, try to think about it in this way, that this x is greater. Okay, it has a greater abundance. Okay, I told you the thing that has more abundance, your relative atomic mass is going to be towards that thing. Okay, so now let's create our boundaries. Okay, don't forget the basics, don't forget the first step, that's creating the boundaries. Now let's create the boundaries over here. Now my boundary is that my mass can either be x or x plus 2. Okay, it cannot be greater or smaller than that. It can either be x or x plus 2. Okay, not above it, not below it, it has to be in between these two. Okay, right over here. Now second thing, I know that my x, the abundance of my x thing is 9 upon 12, okay? 9 upon 12, which I can simplify to be 3 times and 3 4 times. So it is 3 upon 4, and this 3 1 times and 3 4 times. So x plus 2 is 1 upon 4. I hope you understood how I did this. Okay, now I know that, okay, just try to understand this, okay? This x is 3 times more, okay? This is 1 and this is 3 with the same denominator. This is 3 times more, okay? So it has 3 times more abundance, okay? So now if you try to convert anything into percentage, you should know, if you're good in maths, okay, you just convert it into a percentage. You're gonna realize this is my 75% and this is my 25%, okay? I hope you get it, okay? How to convert it into percentage? Simply multiply by 25 or multiply the whole fraction by 100. So 3 times 25, 3 times 25, look, that's 75, and this is going to be 25. Okay, if you are uncomfortable with this, don't worry. You just know this is more in abundance, this is less in abundance, okay? Until now we are clear. So we know that midway between x and x plus 2, what's the midway? Okay, what is going to be the midway? The midway is simply going to be x plus 1, ठीक है? This is going to be the midway, ठीक है? x और x plus 2 के midway में आएगा x plus 1. अब हमें पता है कि ये more in abundance है. This is more in abundance. So our mass is going to be towards this side. Okay, so it's going to be towards this side. Not above x plus 1, it has to be below x plus 1. I hope you get it. ठीक है? Now our mass has to be below x plus 1. Now let's see. So you're seeing this is x plus 2. This cannot be our mass. Our mass has to be below x plus 1. Why? Because this is more in abundance. Our mass is towards that side that is more in abundance, okay? So on the basis of this, that we know it's more than x plus 1, we can simply cross out some of the options. X plus 2 is not possible. X plus 1.5 is not possible. X plus 1 is not possible. It had to be less than x plus 1. And less than x plus 1, there's only one value over here, which is x plus 0.5. Okay, so I hope you get it, how to solve this. Now moving on to the next question about percentage abundance, which is, you know, I guess even trickier. But don't worry, we're going to solve it, and we're going to solve it step by step. Okay. A sample of Q contains 2 isotopes. Okay, the diagram shows the relative abundances and the relative masses of the 2 isotopes. Okay. Now, this is the abundance, this is the mass. Okay. What we're going to do, we're going to just make a table out of this, because I guess this is very confusing, this graph. We're going to just write 20. Okay, 20, this is the mass. Okay, and this is the abundance. Okay, for 20 mass, for this 20 mass, how much is my abundance? My abundance is, I guess, 1. Okay, my abundance is 1. And the next I have 22 mass. For 22 mass, if I go up, my abundance is coming to be 5. Okay, for 22 mass, the abundance is coming to be 5. Okay, now I can simply apply the formula. That's simple. If I even use my common sense, I know that what is going to be the answer, but still, now this one, we can easily apply the formula. The formula is going to be easy. This is the formula, okay? For some MCQs, formula can also be applied. Mass into abundance plus mass into abundance over sum of abundances, okay? So first, let's write down the mass. The mass is 20 multiplied by the abundance, which is 1, okay? Plus the mass of the other thing, which is 22, multiplied by the abundance, which is 5. Okay, over the sum of abundances. Now what's going to be the sum of abundances? Sum of abundances is going to be this. These are the two abundances. So it's going to be 5 plus 1, which is equals to 6. Okay, I hope you get it. And if you don't get it, just write it in the comments below. I'm going to explain it to you again. Okay, the sum of abundance is 6. Now this is simply going to give me my, mass, AR. So 20 times 1 is going to be 20, plus 22 times 5, I guess it's going to be 1. 0, and 2 5 times 10, 11 upon 6. So that's going to be 130 upon 6. Let's find it out. What's going to be the mass? 130 divided by 6. That's going to be 21.66. Okay, 21.66 and 6. Now if I round it off to 1 decimal place, because all my answers are 1 decimal place, so if I round this decimal, this thing, this is going to be checked, 1 is going to be added because 6 is greater than 5, so it's going to become 21.7, so which makes option D to be the correct one. I hope you understood this. Okay, so that was the concept of percentage abundance that is used in questions like these, and the formula is used in questions like these, and these are from recent past papers. I hope you understood, and thanks for watching my video, and all this means a lot. If you consider subscribing, that's going to be a great thing, and bye bye.